name is Carsten Nielsen, and as the speaker said, I'm from the Geological Survey of Denmark and Greenland, in short GEUS. I have a background in chemical engineering, but have worked for the past many years as a reservoir engineer and working with CO2 for many, many years. The title of the talk was Testing Onshore Storage in Denmark. I took the liberty to put a few words in brackets because it could be interpreted that we actually are injecting CO2 into the ground onshore Denmark. We are heading there, but we are not putting any. We are not injecting at the moment. We are injecting CO2 onshore, offshore Denmark in the Green Sand project. I'll develop on the incentives and the framework for CCS in Denmark. The meaning is that we really are in an accelerating mood. We started in 2019 and are with being allowed to inject CO2 into the subsurface. So, first of all, the framework and also how some of the projects are accelerating the deployment. Back in 2019, we was asked by the minister, how long will it take to deploy or to develop CCS in onshore Denmark? And we are experts in the subsurface. We are not experts in developing surface facility, etc. So we came up with a very ambitious timeline saying that in 5 years we could develop CCS. But we are an oil and gas producing country, so we have a lot of experience in using the subsurface for producing and injecting fluids into the subsurface. And we have also a lot of old exploration data. So this timeline in 5 years was without an exploration phase. So in order to get sort of a contract with the authorities and also with the politicians, they have set up a framework with some 4 pillars that has to be conducted. Of course, we should examine could CCS be a means to reduce emissions from especially hard-to-abate sectors, and also, for instance, with negative emissions. There should be an agreement that the politicians should really support a full-scale value chain development in Denmark. And of course, the storage of CO2 in the subsurface should be environmentally sound and safe. There was a sort of a deal that we was not allowed to use CO2 as an EOR agent anymore. And for people like myself coming from an oil and gas background, that was a little bit, odd. We also have a large storage capacity in the area of Denmark, so we would also like to provide ourselves as a hub in the northern part of Europe. So back in December 2019, there was a Legal Climate Act where it was agreed that in 2030 we should reduce our emission by 70%. And also in 2050 we should be climate neutral. There was an agreement that the government should support this development, and there was set up a roadmap in order how to communicate with authorities, stakeholders, academia, etc. to reach the goals. And then we also implemented the amendment to the Article 6 of the London Protocol. We had the ambition that we would also like to be a hub, so it was necessary to be allowed to export CO2 cross borders. There was an agreement that there was a state participation in 20% for the CO2 licenses. That also goes for our hydrocarbon licenses today. National funding were put together, and some research funding was granted to some of the oil companies in order to examine and to develop CCS in the offshore in some of the depleted oil and gas fields. Also, a national funding subsidiary scheme was put together where more than 2 billion euros were put aside in order to develop the full value chain. Several sort of blocks should be fit together. There should be a political agreement And in June 2020, there was an agreement of the CCS law in Denmark, and I have difficult to see this. And the CCS strategy was also put in place. Further on, the license was awarded. There was awarded a pilot test license where the green sand project was awarded to inject CO2 into the depleted oil field. In February this year, there was granted 2 exploration licenses, one for Total and one for Enos, in order to explore some of the saline aquifers in the North Sea. And in May 2023, a full-scale project was awarded to the Danish energy company Ørsted in order to capture and store CO2. And the first injection of CO2 into the subsurface was done in March this year by Ineos in the Green Sand project. So the plan is now, hopefully, the Ørsted will start in 2026 as a full scale with 0.4 million tons per year. Later on, 2027 to 28, Green Sand project will start a full scale injection with up to 8 million tons per year. Total's project, called Bifrost, will start in maybe 2030 and has a capacity of 5 million tons per year. With all this, we have the onshore storage project that is conducted by Gas Storage Denmark, which is an operator that stores natural gas onshore. And they are going from a pilot to a demo and to a full-scale project. We started already in 2020, and we hope that we can have the first CO2 injected into the subsurface in 2025, and that is onshore. We set up these different roadmaps, of course, as a geological survey. The roadmap for storage was what we have focused on, but there was also a roadmap for capture and transportation, and also a roadmap for the use of CO2 as a PTX. Of course, these should be merged together in order to get the full value chain and to get it optimized. Danish subsurface is very suitable for CO2 storage. We have a lot of thick sedimentary rocks above the pre-sextine, and we have, due to salt tectonics, we have a lot of trap structures, or a lot of dome structures in the subsurface. And in order to convince the public and get public acceptance, we could tell them, as with our experience as a hydrocarbon producing country, we could say that, okay, the way that hydrocarbons has been accumulated in millions of years, it is exactly the same way that we would like to store the CO2. In 2020, GEUS was funded to study several of the structures onshore. So we evaluated 13 of the structures and prioritized them, meaning that we could get additional funding to a new project where we have to mature some of these structures. We picked 5 structures onshore and one near shore and 2 offshore. And we got a lot of funding in order to acquire new seismic data. So maturation of the Danish structure for CCS. I'm sorry, a little bit confused because it's not the right presentation. So sorry. Okay, being an oil-producing country since the early 70s, we have a lot of vintage data. We have a lot of seismic lines shown here with the blue lines, and we have a lot of deep exploration wells. And see, most of the exploration wells and seismic lines are in the Danish oil and gas province to the west of the coast of Denmark. But we do have some deep exploration wells, and we do also have some seismic lines onshore Denmark. There was, in the early 50s, 60s, exploration after hydrocarbons onshore, and there has also been exploration after geothermal energy onshore. But in order to improve the database of the different structures, new seismic lines were acquired, shown here with the red lines covering the part of Denmark where we have screened out which will be the most promising structures. And to the right, you can see sort of the program starting out in February 2020, with acquiring data on the Stenlille structure, and then running down to this year, October this year. Actually, they are shooting this last line as we speak. So you can see it's a very accelerated data acquisition program. I can't recall how many kilometers of lines, but it's more than 300 kilometers of lines, seismic lines. And it was done with the same acquisition setup, so it had to be done in a series. So we set up a program. How can we accelerate all the data acquisition? It has to be a series because we only have a few trucks for the acquisition. But of course, all the data processing, reservoir characterization, all the analysis can be done in parallel. Going on to the onshore, we have two natural gas storage facilities in Denmark. One to the north, which is a cavern, a set of salt caverns, and one on the sealand, which is in the middle of Sealand, which is in a sandstone reservoir, and it's the same with a four-way closure, and the sandstone reservoir is in the Gasum Formation, which is a well-known sandstone deposit that is covering most of the area of Denmark. Above, we have 300 to 600 meters cap rock consisting of mudstone and shale. The natural gas storage facility has been in production since 1989, and it has run without any leakage. Now, in order to develop a CCS demonstration in an aquifer, we was allowed to use the northeastern flank of the structure. This is a top view of the trap used for the natural gas storage. In red colors, we have the gas accumulation. To the northeast, we have a flank that has not yet seen any natural gas, and we thought that could be used to demonstrate what would happen if you inject CO2 into a saline aquifer. So the plan was to drill two new injection wells, an appraisal well and an injection well, and also use one of the existing observation wells that was drilled for the observation of the natural gas facility. So we had to shoot new seismic lines because you can see here the model is not extended, so we have to extend the model. So new lines, new seismic lines were acquired in the northeastern part of the area. And due to surface logistics, we have to, for most of the lines, they have to follow roads. You are not allowed to go across the fields. The old model, simulation model, was run in the beginning, and it was used by the same model that was used for the gas storage facility. But you can see we lack data here, so we have to extend the model. So we shot a lot of seismic lines, and with the setup that we have, two trucks used to vibrate the subsurface. Geophones were placed as both wireless geophones, but there was also geophones that was sort of placed as a land streamer and was behind the rocks. The area that was acquired was to the northeast, and here you can see a share of the seismic data. It was done in cooperation with Uppsala University, so it was sort of a research project / a consultancy project. to come up with a field development plan. We got the new seismic data, so we could delineate the northern flank. We could delineate where was the spill point for the structure. And then the plan was to convert an existing observation well and drill 2 new injection wells. They are planned to be drilled from down to 2.5 kilometers in order to use some of the underlying reservoir zones that is in the structure. At present, we are only using the top of the chasm, but there are more reservoir of good qualities, and even further down, there is there are several other sandstone formations that have the potential to be a good storage facility. Simulating some of it. Here showing that a base case where we have made a reservoir model for the northern flank, and we have simulated the distribution of CO2 after injecting in 20 years, and we have injected 200,000 tons per well, meaning as a 400,000 tons per year in 20 years, summing up to a total of 8 million tons. So after injection stop, we have the development of the CO2 plume. And one of the things that was a little bit problematic by using a natural gas facility is that the gas facility operator would like to keep his natural gas storage facility in operation for maybe 20 to 30 years more. So here we have the Stenlille 1 well, which is in the edge of the natural gas accumulation. So after 20 years of injection, you can see there's quite a distance to the natural gas, but after 80 years of equilibration, the CO2 plume starts to move onto the natural gas accumulation. And will not be a problem, because at that time we anticipate that the natural gas storage operation is finalized. But there was some kind of you can say, it was a little bit problematic when everything shall be accelerated. So the politicians sometimes do not sort of have the technical background. So first they promised to support a pilot downflank. Then they started to be greedy. Said, okay, could you have more than 100,000 tons put into the ground? Maybe 2.5, that would be great, because in the Climate Act they have promised that we will have 0.4 million tons per year CO2 stored from CCS. And then they also said, okay, if you can do 2.5, you can also do maybe 8 or 10, and then you can be a part of this call from the ministry that you could set up a full value chain project. And that full value chain project will be granted more than 1 billion euros. Unfortunately, Gas Storage Denmark was not awarded the grant, or the grant. So now they had to sort of go back to the draw and say, okay, we still want to do the project, but then we'll have to do it in 2 phases. Phase 1, we will try to have injection by end of 2025. The technical solution was to use one of the already existing wells. And all the CO2 transportation should be done by trucks, so all the facilities to receive CO2 is by truck. And the objective for the Gas Storage Denmark was to do a fast track, so we could establish a lot of experience that can be used further on. So in the first phase of the project, we estimated a total capacity around 3, maybe up to 10 million tons. But we could only inject around 0.2 to 0.3 million ton in a single well. For the phase 2, that was sort of the larger project that was not granted in the first place. The plan is to drill 2 new injection wells, and the design for transportation and receiving the CO2 should be both for trucks but also for pipelines. The objective, again, try to deploy most of the flank for CO2 storage, and again pave the way for full-scale Danish CCS. So moving from Stenlille to one of the other structures that has been evaluated. And then we can have an estimated capacity of more than 10 million tons. Again, injecting 0.5 to 1 million tons per well per year. And I think the last slide, just to be a little bit on Norway. The project that was granted the national funding scheme was a project that was developed by an energy company, Ørsted. And their plan is to capture both from an incineration plant in Copenhagen, but also in a power plant in the city of Kalundborg. Then the plan is to ship, here comes the tricky part, ship the CO2 from Kalundborg onto the Northern Light project in Norway. So we are shipping national funding to Norway so they can develop their storage complex. That's a little bit, yeah. No, it gets worse because some of the CO2 is captured in Copenhagen, transported to Kalundborg, and here is Stenlille gas storage facility. So they're running just above. So, thank you. Oh, I think this was the last one. Thank you.
Maybe you should say no more.
Yeah.
Thank you, Carsten. I'm guessing you're Iselin. We have never met before. I would like to introduce our last speaker for today, Iselin from BRTM. She's the project manager of the